Photon Hunter, China's quantum radar that sees the invisible. For decades, stealth technology has ruled the skies. Fighter jets like the F-22 Raptor and F-35 Lightning II were designed to be ghosts, nearly invisible to radar. But in the race between stealth and detection, a new player has entered the battlefield. China calls it the Photon Hunter. So what makes this radar so different? And why is it making military scientists around the world pay attention? Let's start with how traditional radar works. Conventional radar systems send out radio waves that bounce off an aircraft and return to the receiver. By measuring the time it takes for the signal to return, the radar calculates distance, direction, and speed. It's reliable, but also limited. Stealth aircraft are built with radar-absorbing materials and special angles that scatter those signals away. The result? Almost no reflection, and the jet practically disappears from the radar screen. That's where quantum radar comes in. The Photon Hunter isn't just another high-frequency radar. It operates on the edge of physics, using the strange principles of quantum entanglement and single photon detection. Here's how it works. The radar creates pairs of entangled photons, tiny particles of light that share a quantum link. One photon is sent out into the sky, while its twin stays behind as a reference. When the radar receives a return signal, it checks if the photon matches its twin. If the link is still intact, the radar knows it's a true signal, not random noise. This allows the Photon Hunter to detect even the faintest reflections, signals so weak that ordinary radar would miss them completely. And that means stealth aircraft, which rely on minimizing reflections, could finally be revealed. In other words, the F-22's invisibility might not work against this new generation of sensors. But how does it compare to modern radar systems used today? Advanced radars like AESA, Active Electronically Scanned Array, use thousands of small transmitters to rapidly steer beams, track multiple targets, and resist jamming. They're powerful, precise, and battle-proven. Yet, they still rely on classical physics, sending strong electromagnetic waves and hoping to catch enough reflection to form an image. Quantum radar, on the other hand, plays a different game. Instead of power, it uses sensitivity. It can detect the presence of a single photon, the smallest possible unit of light, even across long distances. This makes it potentially ideal for spotting stealth objects or drones that traditional radar might never see. But there's a catch. Maintaining quantum entanglement in real-world conditions is extremely difficult. Atmospheric noise, temperature, and distance can easily break the fragile quantum link. That's why many scientists believe China's Photon Hunter is still experimental, more of a prototype than a deployable weapon. Still, reports suggest that China's Anhui Quantum Information Center has already begun mass-producing a 4-channel single-photon detector, a core component of this radar system. If true, it would mark a major step toward operational quantum radar, and a huge leap in electronic warfare. So what would it mean if the Photon Hunter really works? It could change everything. No aircraft would be truly invisible anymore. Stealth, the backbone of modern air superiority, could lose its advantage overnight. And that would force the world's air forces, including the US, to rethink the way they design future fighters. For now, the Photon Hunter remains shrouded in mystery, half science, half strategy. But one thing is clear, the race for quantum supremacy in radar has already begun. Photon Hunter, the radar that sees what others can't.